everyone. Today we're going to talk about Interdigital and Interdigital's research in 5G wireless standards and beyond 5G. So what I have here, give you a timeline of where we are with 5G standards. The 5G work in 3GPP has started in 2017 with Release 15. Release 15 supports both standalone and non-standalone versions. And as you can see, we've completed Release 15 at the end of 2018. Work is ongoing today for Release 16, and Release 16 is expected to finish sometime in early 2020. A drop at the end of July 2019 will go into IMT 2020, which will become the official 5G standard. And then we'll have Release 17 and 18. This is a tentative timeline that we think will go forward. As you see at the top, this is what's happening in terms of deployments. There have been proof of concept and other trials in 2017 and 2018. 2019, we are seeing city-level 5G deployments. In 2020, we expect to see commercial at-scale deployments throughout the world. And 2021 and 2022, our expectation is that we'll start to see more densification and national coverage. In Release 15, we have seen topics such as eMBB and URLLC that all of you are familiar with. And in the network, we are starting to see things like network slicing and service-based architectures. In Release 16 and 17, we'll start to see more use cases, interesting use cases such as industrial IoT. That's a big part of it. URLLC extensions that were not covered in Release 15. We'll also see other use cases and deployments such as V2X, unlicensed, satellites, drones, and so on and so forth. Interdigital is very active in 5G's wireless standards beyond 3GPP. In 3GPP, we're active in all RAN standards, from RAN 1 to RAN 2 to RAN 3 and RAN 4, both SA and CT as well. We are very active in IEEE 822.11 standards. I've listed a few of these standards here, but we also cover other aspects. We're also very active in Multifier. Multifier is doing standalone unlicensed. They've done their work. Multifier 1.0 does standalone LAA and ELAA. And the Multifier 1.1 covers eMTC and NB-IoT. They're starting to look at standalone NR and NR millimeter wave. Here, just to give you a picture of our standards leadership, Interdigital is very active again in 3GPP. We have chair and vice chair positions in CT, RAN, and so on. We're also very active in other parts. In 822.11, as you can see, we have chair and vice chair positions in 1M, 2M standards, and there are a lot of other standards that we're very active. For example, drones, we're very active in drone standards as well. This slide here, I just wanted to give you an update. I give you an update on what's happening in Release 15, Release 16, and beyond. As I mentioned earlier, Release 15, it supports the main use cases of eMBB and URLLC. Also has MMTC coming from LTE. We also support standalone and non-standalone versions here. The standalone version is connected directly to a 5G core network. In the core network, we have concepts such as network slicing and service-based architectures that are already complete in Release 15. Release 16 is extending this to newer use cases. Cellular V2X has started standardization in LTE. For example, Release 14 and 15, there's been quite a bit of work in cellular V2X. What's being done in Release 16 is more advanced use cases such as platooning, extended sensors, and interworking between LTE V2X and NR V2X. NR V2X will be backwards compatible with LTE V2X, so it will build on the features that are already there in LTE V2X and extend that. Release 16 will also have work related to NR unlicensed operations. This is mainly sub-6 focused. They'll support both standalone and non-standalone. There's also ongoing study items in non-terrestrial networks. Industrial IoT will be a big focus area, having both study and work items in Release 16, supporting more mature use cases there. Integrated access and backhaul is another study and work item in 3GPP, enabling more faster small cell rollouts. And from the core network perspective, similar features are going on, but there are significant enhancements to service-based architectures that will happen here. There's also focus on private 3GPP networks. Beyond Release 16, we think there will be more work items and study items. This is Interdigital's view. These are just being talked about, but these are not agreed on yet. You will see things like full autonomous support for full autonomous driving, more infrastructure and on-demand dynamic network slicing, further support for more mature industrial IoT use cases. You start to see things like 5G broadcast, and there's already, in terms of the SA work today, there's already some work going on in terms of steady items in unmanned aerial vehicles, and there's also multi-hub UV relays that are going on. So with that, what I want to do is give you Interdigital's thoughts on where we are evolving with regards to beyond 5G. So far what we talked about is really 16 and a little bit beyond. So this sort of picks up from where we left off on the other slide back here. With 5G soon, this is what we expect to see roughly up to 2020-ish, 2022-ish time frame. So this will be more release 17 and 18 of 3GPP. So this builds on the 3GPP standards roadmap. We talked about what sort of things that could go on there. In terms of true beyond 5G, we think the midterm for that will come more towards the 2025-ish time frame. This will leverage the forward compatibility that 5G-NR has got. 5G-NR has got a very flexible framework, as you're aware of. So we'll leverage that and start to build more advanced features such as full duplex. I think at this point we believe the satellite technology will become quite mature in 3G. We'll also look at unlicensed 5G millimeter wave, distributed massive MIMO, so on and so forth. From a network perspective, we start to see SB a microservices vision, more AI-based intelligent dynamic networking that we start to see, pushing virtualization all the way to the device, and we start to expect to see some of the flattening of the protocol stack. So here I think we're starting to break concrete in terms of how the IP has evolved in the internet and leading us to the network, towards the network 2030 vision for the network. So if you look at for the beyond 5G long term, we are starting to rethink the radio access altogether. Now we are going to look at support for terabits per second for the use cases that need that. You will see pervasive AI everywhere, and the impacts of that. You will start to see low power designs, holographic communication, so on and so forth. So let's jump here and get a better view for what we believe are the key areas that will drive beyond 5G. So we have, for simplicity, we have broken this into 4 quadrants. You'll start with the leftmost bottom quadrant, where we start to talk about the drivers, the key drivers for beyond 5G, what sort of immersive applications and user experiences that you expect to see beyond 5G, and why we'll need something where we need to leapfrog from 5G to beyond 5G, leading towards 6G. We'll talk about some of the key technologies that we believe could be part of the air interface design and could influence this beyond 5G vision. Same with the network. We'll talk about some bold new architectures and a complete rethink of how we've been looking at the internet architecture leading towards 2030 and the role that AI plays there. And then we'll also talk about some of the revolutionary terminal architectures. Again, as we said before, leveraging virtualization all the way into the terminal and truly enabling pervasive user experiences. So now let's jump a little bit into what sort of deep dive into what could be some of these immersive applications and services that we will be focusing on. First, we believe there will be this need for blurring the user experiences between the physical and the virtual world. So you will start to see more captivating user experiences. As we have seen, video has been progressing dramatically. We have seen from standard definition to high definition to full HD to ultra HD to 4K to 8K to 6 degrees of freedom to now leading towards more volumetric video, 360-degree VR and MR, and then you start to see more of this holographic communications. And once you start looking at these applications, the needs for data rates go significantly higher. If you truly want to enable holographic communications for a human, who's let's say 6 feet tall and maybe 2 feet wide, you're talking terabit per second data rates anywhere between 4 to 10 terabits per second with sub-millisecond latencies. These are the sorts of data rates that 5G is not capable of supporting. Today 5G goes up to 20 gigabits per second, but moving into terabits per second, multi-terabit per second is something that where we need to leapfrog more towards 6G. And then we start to talk about guaranteed high precision services. Guaranteed is the key word here. When you start to think of the control loop and the kind of precision that will be required for this fast machine interaction for extreme industrial automation, you're talking latencies as low as tens of microseconds. This is an order of magnitude or more lower than where you start to see with the 1 millisecond latencies that we see in 5G. This again pushes the need for moving towards the 6G vision. And the third aspect here, you're talking about enabling the full human sense perception with use cases such as tactile internet, enabling the full digital senses beyond voice and vision that we are limited to today, looking at haptic communications and so on. Now, jumping into what are some of the key technologies that we believe that would be critical for 5G, beyond 5G air interface, you start to look at things like terahertz radio. With advanced modulation schemes, I think what's really required is now you start to look at the terahertz spectrum, you need to really focus a lot on processing. How are we able to get this into our terminal form factor? There are multiple challenges here, and we are working with the European partners here, with our European partners in the EPIC, where EPIC is one of the key projects that we're focused on. It's part of the Horizon 2020 cluster and networks beyond 5G projects, where we are focused on looking at the FEC technology, where we want to truly enable a 1 terabit per second data rates. And there are several EPIC FEC KPIs that we have that have been put together from the consortium, and we are targeting towards this right now. Going back, one of the other aspects that we think will be key towards beyond 5G is ultra-low power communications. If you start to think about how many devices that we will have in this beyond 5G vision, you're really talking trillions of devices. When you start to have these trillions of devices, changing batteries and replacing batteries will not be viable. For example, if you think of, you have 5 trillion devices, then you need 1 billion battery changes per day. That's insane, that's not viable. So we need a vision where we can start to have 30-year life cycles for these IoT devices, or truly talk about battery-less operations. You're talking about ultra-low power cable receivers that operate under 10 nanowatt budgets, and based on our research, we believe this is viable. Other aspects that we think from an air interface perspective that we believe are interesting are AML-assisted wireless. We start to look at more forward-looking things such as quantum communications, go beyond Shannon, and then satellites is a big aspect of here, and here we believe you start to see very low Earth orbit satellites with constellations like the likes of what SpaceX and others have been talking about. Here you're talking about tens of thousands of satellites covering the whole entire Earth, providing ubiquitous connectivity, connecting the rest half of the world, and providing fairly low latency applications. That's why you're starting to bring the satellite from the GEO to MEO to LEO, and here we are talking about distances such as up to 1250 kilometers from Earth and things of that nature. Moving towards network, we think one of the key things that's necessary is what we call name-based microservice chaining. Here we reduce the Internet protocol stack from the existing OSI 7 layers to a maximum of 3 layers through name-based routing. We're also looking at in-packet metadata IP extensions here, looking at not only the quantitative aspects, but we're also looking at the qualitative aspects of the data. So you have this metadata that we want to enable this distributed computation along the end-to-end path. We're also talking about localized networking, moving into more forward-looking things such as quantum networking and AI-assisted dynamic control, where the orchestration is done dynamically to assemble resources across different tendencies and domains using AI. The last aspect that I want to touch on is looking at how will the terminal architectures evolve and look like. We believe from a mobile function offloading in terms of getting the virtualization all the way to the terminal will be very important. When we started looking at memory structures, we believe deep learning structures will be necessary in terms of replacing the linear memory access that we have. We'll start to see new fog node architectures and new radio architectures where we want to leverage high degree of parallelism when you want to support large bandwidths such as the terahertz, that what becomes available in the terahertz spectrum. With that, I'll close here. Thank you very much.